Hello students, welcome to the classroom chemistry. Today I am going to explain you the lattice energy, lattice enthalpy and the enthalpy of lattice formation. These all three terms are synonym to each other. So I have a homework on the blackboard to make you understand, and I will try my best to make you understand about the lattice energy or the lattice enthalpy. So to make you understand, I have a question. I start this video from a question. The question is the how much energy required to separate or make gaseous the constituent ions of 1 mole of an ionic compound. So this question has several technical terms. So first of all, I will explain these technical terms or the chemical terms. So first is ionic compounds. So I am telling you that this lattice energy, lattice enthalpy or the enthalpy of the lattice formation all are related to the ionic compound or the electrovalent compound, or you can say this lattice energy is related to the crystal formation of a crystal. So again, I think that so for this ionic compound, I have taken the example NaCl. NaCl is an ionic compound. Again, the 1 mole of ionic compound, 1 mole, you are very familiar with the 1 mole, the mole concept of the compound, that 1 mole is equal to has 6.02 into 10 to the 3 molecules, and it is also equal to the molecular weight of the compound. So there are 6.02 into 10 to the power 3 molecules in the 1 mole of ionic compounds. Now the third term, chemical term, this is the constituent ions. What do you mean by the constituent ions? So constituent, the NaCl is made up of two types of the ions, that are the sodium ions and Cl ions. These two types are called the constituent ions. So this NaCl consists of Na positive and Cl negative. This Na positive and Cl negative are called the constituent ions. Now, this number of molecules in the NaCl is in the form of NaCl molecule, and each Na and Cl is attracted to each other from electrostatic forces. So, and again, this NaCl is in the form of a crystal. So, in the crystal, you know, each sodium atom is surrounded by 6 Cl ions. Each sodium ion is surrounded by 6 chloride ions. So, I have shown you the 4 chloride ions. One chloride you can show on the upward side and one is by the behind side. And again, vice versa, contrarily, the chloride ion is also surrounded by the 6 sodium ions. I have shown you the 4 ions in this way, and with the 5th ion you can put Na positive on the forward side, and the next one is the 6th one is the backward side. So in this way you are familiar with the crystal lattice of the sodium chloride. Now the question, you require the energy. So I am giving to this energy, this NaCl, the number of molecules are in this, because we have taken the amount 1 mole. This energy will separate these Na positive and make them gaseous. Here NaCl is in the form of solid and here these Na positive and Cl negative are have no attraction between each other. They are in the form of gaseous state. They are free to each other, or they are separated by this energy. So this energy, how much this energy is required, and this energy is called, the amount of this energy is equal to the lattice energy. The answer of this question is lattice energy. The answer of, I will say, the lattice enthalpy, or the enthalpy of the lattice formation. So I have told you the definition of lattice energy or the lattice enthalpy. Here only you can replace this, the how much, the amount of energy required to separate or make gaseous constituent ion of 1 mole of an ionic compound is called lattice energy. It is the definition of the lattice energy I have explained. So think about, visualize about that we have 6.02 into 10 raised to the power 23 molecules of NaCl or any ionic compound, and we have to separate these constituent ions in a gaseous state. We have make them in gaseous state. Within gaseous state, no ion has any attraction with each other. Na positive and Cl both are separated, and all the ions are separated from each other. So the energy required to get that stage is called the lattice energy. Here again, again I am telling you that these are the molecules, and after separating these ions, constituent ion Na positive, 6.02 into 10 3 ions of the sodium ion, and the same here these are the molecules, and 1 mole of sodium ion and 1 mole of chloride ion will be formed. So see here, this is the equation, this is the equation. Again I am telling you that when this is, suppose in this stage the NaCl and positive we have ions, when we cool down, when the temperature is brought down, the NaCl will be, Na positive and Cl will be attracted to each other to form the NaCl. Then the energy will be released here. So in this way, again this way. So that is called the enthalpy of the lattice formation, because the ions come close to either, release the energy and forms NaCl solid as a crystal. So this is called the enthalpy of lattice. So again I am telling the enthalpy, the energy absorbed by to separate the constituent ion, or the energy released by the combination or by the attraction of the ions is equal. So it is called a lattice energy or enthalpy of the lattice formation. I think that you have understood about the thing. Now I am relating to the lattice enthalpy. So here, suppose this is the system. Here we have the crystals of the sodium, this is, and the number of molecules may be this 6.0. When you will provide, or when it is heated, or the energy is given to this system, the energy will be increased, and the all ions will be separated from each other. This is the gaseous state of ion, and this is the solid state of NaCl. So here in this case, the system of there is an increase in the energy of the system. So H2 is greater than H1. H2 is, hence the delta H is equal to H2 minus H1. H2 minus H1. So as the H2, S2 is greater. So here delta H, the lattice enthalpy will be positive. So again I am telling you this is this is endothermic because energy is absorbed in this reaction. So it is endothermic. When in the endothermic reaction the enthalpy, the lattice enthalpy you will find in the positive. And again take the case, suppose these are the gaseous ions of the NaCl I have taken here. Again when the temperature is decreased, so again these ions will be come to the in the formation of a crystal. So this is the H1 here, H1 and S2. S2 is less than H1. This is the energetic part. This is part of the system, and we have decreased the temperature. So S2 is less than 1. So again here delta H is equal to negative, and this reaction is exothermic. So when the reaction is exothermic, the delta H, the value of delta H is negative, and this enthalpy, this is the enthalpy of the lattice formation, because here these all ions combine with each other to form a crystal lattice. So this energy is called the energy which is released from this reaction will be called as the enthalpy of the lattice formation. Enthalpy of the lattice formation, this will be minus. And again I am telling you the NaCl, the enthalpy of the lattice formation of sodium chloride, delta H is equal to minus 788 kJ per mole. So the unit of the lattice energy is 684. So again, I think that I have explained you and you have understood it very well. Now I am going to explain you by the second method of the lattice energy. This is the gaseous state. Now I am taking the help of the solution by the help of the crystallization. How does the crystallization takes place? So I have some question to explain you. It's the second method to explain the lattice energy or the lattice enthalpy. For this, I have also a question for you, that the crystals are formed on cooling of saturated solution. Why? When we cool the saturated solution, or the temperature of a saturated solution is decreased, the crystallization starts. Why? So here, first of all, I am going to explain you the saturated solution. Suppose I have 500 milliliter volume of water on 25 degrees centigrade. So here two things are very important. One is the temperature is fixed, so and the volume of the solvent is also fixed over here. Now I am going to dissolve some amount of NaCl. Finally, the amount of 40 gram amount of NaCl can be dissolved in this here. So again, after 40 gram of NaCl, no more amount of NaCl can be dissolved in this solution. So this solution is called as the saturated solution. So if anybody asks you what is the saturated solution, so you can explain. It is a state of solution in which no more amount of solute can be dissolved in a fixed volume of solution on constant temperature. So it's the definition of the saturated solution. Now I raise the temperature by heat it and raise the temperature up to 25 to 60. So the the more amount of NaCl can be dissolved in this same saturated solution, and now I find that 85 gram of NaCl can be dissolved on the 60 degree centigrade in the same amount of the same volume of the water. Now it is the second saturated solution of NaCl in the 500 milliliter water. Again, I raise the temperature 80 degrees, 60 to 80 degrees centigrade, and I found some more amount of NaCl can be dissolved in this NaCl, and finally I found that 125 gram of NaCl can be dissolved on this temperature. So this is there are three saturated solutions which have the constant or the similar volume and the temperature, the different there, because this is 25 degrees centigrade, it is 60 degrees centigrade, it is on 80 degrees centigrade, and the amount 40, 85, and now start the cooling. The crystallization will be start. Why? Because the capacity of this saturated solution is 125. So this amount of water can dissolve 125 gram and on 80 degrees centigrade, and the capacity of this same amount of water at 60 degrees centigrade is 85 gram. So on cooling, when you cool down this temperature from 80 to 60, the capacity will be lowered by 125 and 85. So the 40 gram of NaCl will be changed into solid as a form of crystal. So when you found in the saturated solution, these Na and positive, these NaCl, Na positive, and these are found in the form of Na aqueous. I will explain you in the later video what are the Na aqueous, what do you mean by Na aqueous, and this is Cl negative aqueous. So these are the aqueous. They are isolated with each other. They have no attraction with each other because ionization takes place here, NaIon and Cl and NaIon and Cl. When you will cool it, this saturated solution, the Na positive and negative ion will be associated with each other, will be connect to each other to form NaCl. So here again the energy is released. This energy called the lattice energy, and because here especially you can say this is the enthalpy of the lattice formation, because here the crystals are formed in this by releasing this energy. So it is called the enthalpy of the lattice formation. Again, positive, negative. This is positive and negative. Positive ion will associate with this here, negative and the positive. Again, this is positive, negative, positive and negative. Positive, negative, positive, negative. So this release of the energy is called especially the enthalpy of the lattice formation. So I have explained this in the second way. With the help of a saturated solution, you can explain the lattice energy or the lattice enthalpy, especially the enthalpy of the lattice formation. This is the enthalpy of the lattice formation. So I think that I have explained the lattice energy and you have understood about it. Lastly, you should share this video to your friends, those who are preparing from their hometown and they have no any source of to join the coaching or the tuition. So please share this my video to those students and like it. That's all for today. Thank you very much.